January 22, 2018. The Pryor Trust gas well in Pittsburgh County, Oklahoma. The well was operated by Red Mountain Operating, LLC, which contracted the Patterson-UTI Drilling Company to drill the well. In order to change a drill bit, crew members removed the drill pipe from the well. Approximately 3.5 hours later, a blowout and rig fire occurred, killing 5 workers.
Industry best practices recommend having 2 protective barriers in place at all times during drilling operations. But our investigation into the incident at the Pryor Trust well found that both of those barriers failed. The safety management system utilized at the well was simply not effective, and the result was a catastrophic blowout and fire.
Pryor Trust gas well was comprised of vertical and horizontal sections being drilled to reach underground natural gas in the Woodford Geological Formation. During drilling, a diesel oil-based liquid called mud is pumped down through the drill pipe and back up through the area of the well outside of the drill pipe, called the annulus. When mud returns to the surface, it includes rock cuttings from the bottom of the well. Mud, however, has another important function. It is designed to add pressure to the well so that gas within the exposed geological formation is unable to enter the well during drilling. If that happens, and the gas is not detected, it can lead to a dangerous blowout. On January 21, 2018, Patterson crew members had been drilling the well for 10 days under the supervision of 2 contracted representatives from Red Mountain. They were drilling the horizontal section of the well. That morning, a crew member called a mud logger studied the rocks returning to the surface and found they were different than expected. He believed the drill pipe had inadvertently entered a different geological formation where Red Mountain did not intend to drill. Shortly after, gas started to escape from mud returning to the surface. The gas caused mud to spit out of equipment near the well and cover a portion of the rig. Around 11 a.m., the drilling crew adjusted piping so that mud returning from the well was routed to a piece of equipment called a mud gas separator that removed the gas from the mud. The separated gas was then routed to a flare to safely burn it. The size of the flare indicated that there was a significant amount of gas in the mud and that the well had likely become underbalanced, meaning that pressure from the mud was not keeping gas out of the well as intended. The crew continued drilling underbalanced until 3:30 p.m. when they stopped because the drill bit had become worn and needed to be replaced. The crew first circulated the well for 3 hours by pumping mud down the drill pipe and up the annulus. The flare continued while the well was circulating, an indication that the well remained underbalanced. While circulating, the Red Mountain representatives discussed how to remove the drill pipe from the well in order to replace the drill bit. The process to remove a drill pipe is called tripping. During any tripping operation, mud is pumped into the well to replace the volume of drill pipe being removed, which prevents gas from flowing into the well. In this case, the Red Mountain representatives decided to use a tripping method called calculated fill, which involved periodically pumping a calculated amount of mud into the well as the drill pipe was removed. They believed this method would keep the well contained if gas entered during the operation. But it was not a standard tripping method during normal drilling, so no one on the Patterson crew had performed it before, and they had no written procedure. The crew started removing the drill pipe at 6:47 p.m. The CSB found that while tripping the drill pipe from the horizontal section of the well, not enough mud was pumped and gas entered the well. The driller, who was controlling the operation from inside a building on the rig called the driller's cabin, did not see the discrepancy. That is because he had not been sufficiently trained on a new electronic version of a trip sheet, which is a form used to monitor and calculate whether a well is taking the proper amount of mud during tripping. As a result, he was unable to see that a significant amount of gas continued to enter or expand within the well, causing pressure in the well to increase and mud to backflow into a tank at the surface called the trip tank. In fact, pressure at the surface of the well had increased so much that the centrifugal pump the crew was using was no longer able to pump mud against the pressure of the well. Red Mountain's representatives decided to switch to higher pressure pumps, called mud pumps, to try to force mud into the well. They believed that the pressure applied by the new pumps would push any gas out of the well. But by the time the drill bit reached the top of the curve in the well, the CSB found that, unknown to drilling crew members, 20 barrels of gas had entered or expanded within the well. At that time, the drilling crew performed a 45-second flow check to see if gas was flowing in the well. The crew did not observe any flow of gas and believed the well to be stable, but the CSB determined that the flow check was inadequate. At 11 p.m., the drilling crew again circulated the well. While circulating, the rig's mud pits, which are tanks used to hold mud at the surface and are equipped with level sensors, gained 14 barrels of mud when they should have remained stable. This meant that the well gained approximately 14 barrels of gas, which caused the mud to escape at the surface. But the night shift driller had turned off the alarm system before the tripping operation, and no alarm sounded, so the large gain went unnoticed. Red Mountain's representatives then decided to pump a weighted volume of mud, called a pill, into the well, meant to generate enough pressure to prevent gas from entering the well. But a Patterson drilling crew member misheard Red Mountain's instructions over the radio, and they accidentally added lost circulation material to the pill. This material is designed to clog breaches in the well and is not intended to be in weighted pills. Although the mistake was discovered, the pill containing the lost circulation material was pumped down to the bottom of the drill pipe, clogging it. By 1:12 a.m. on January 22nd, the crew started to remove the drill pipe from the vertical section of the well, this time using the typical industry tripping method called continuous fill, where mud is pumped continuously into the well as the drill pipe is removed.